Every day our world is getting smarter, faster, and more connected. For more than 60 years, NXP has pioneered the ideas that have propelled us forward. The radio power group of NXP continues to lead us towards the future through innovation in the most advanced technologies for a world with insatiable demand for information. Today, we are joined by a panel of industry experts to talk about the next breakthrough in cellular communications, 5G. There are 4 panelists with me today. We'll virtually go around the room so each person can introduce themselves, starting with Dan.
Hi, everyone. It's a pleasure to be here today. I'm Dan McNamara, Principal Analyst at Mobile Experts. My primary areas of research are base station infrastructure and then the semiconductor content in both base stations and cellular handsets. In my experience, really my entire career has been in the RF world, either as a designer or applications or marketing or business development. So it's an exciting time to be doing this work. Thanks.
Hi, I'm Tom Watson. I'm the director of the IWPC. For those of you that aren't familiar with us, we're an industry association. There's about 150 odd companies globally that are members. And in normal times, we put together technical workshops around the world on topics largely driven by the carriers that are interesting for the industry. And I've been in the industry about 20 years, and I've done a startup, which brought me here to IWPC and tunable RF components for handsets.
Hi, my name is Jim Norling. I'm the Vice President and General Manager of the High Power Solutions product line within Radio Power at NXP. I've got about nearly 30 years, all in RF. And the high power solutions is really the high power discrete and IC solutions, primarily for communication systems.
Thank you, Jim. My name is Pierre Piel, and I'm the Vice President and General Manager of the Integrated Power Solution product line at NXP. And I've been in RF power for the past 20 years in functions from design to product management. My focus today, the focus of my product line is massive MIMO integrated modules, 50 ohm in and out, serving the 5G massive MIMO market.
Great, thanks everyone. So let's get started. So there's so much buzz around 5G these days. In what ways do you think 5G will be evolutionary, and how will it be revolutionary in terms of user experiences?
Maybe let me start. So, 5G is a super exciting time, and part of that excitement, I think, is it's still really all in front of us. We're really at the beginning times of what 5G is going to be doing. And with all the prior generations, we've definitely had this expectation that things are going to get better every time, and I think they have. And 5G is going to be no different, but it's going to be more profound, I think, in ways that people don't really expect. And if you take a step back, you think about 2G world, people are so excited that they could put a phone in their hand that wasn't connected into the wall. And then 3G came along and, hey, it does more than voice and text. That's pretty cool. And then 4G, where we are today, lots of data, lots of videos, all these awesome things that you can do with your smartphones and other connected devices. It's really incredible. And 5G is going to be a lot like that. And it's really enabled by 4G. 4G really set the table. It's the baseline that's going to get used for all the 5G networks. In fact, the 5G that rolled out last year in 2019 and even still today is linked to 4G. So it's called non-standalone. You have the 5G network in conjunction with 4G. And so you're getting a lot of these benefits already, even in a sort of a partial implementation of 5G. And so now the other thing I wanted to mention is 5G will have not only the massive increase in speed and data from smartphones, it's also going to have other aspects to it, like this massive IoT, where there's going to be millions and billions, really, of connected things to the network. And then furthermore, there's going to be this low latency network that exists that's really going to help businesses. You're going to have these automated factories where you're going to have robots running around and massive data being collected. But now you have the ability to process and feedback results almost instantaneously. That's something that really hasn't happened before. And other applications of that are going to look like telemedicine, which is happening today, and even gaming. So there's a lot of really exciting and different things happening with the 5G network.
And I can jump in here. As far as evolutionary versus revolutionary, I think it's fair to say that new radio is more of an evolution of 4G. It's still a OFDM-based system, but that has wider bandwidths, and they did quite a lot to improve signaling and frame structure and these sort of things, which will all help to improve the throughput of the devices. But really, I think from an operator's perspective, given their need to cut costs and find new sources of revenue, a lot of the core network functionality is really going to be important. Things like network automation from a cost-cutting point of view, so you don't have to scale the number of people as you scale your network to manage it. Things like network slicing is going to give them the ability to provision services and offer new services on the fly, all with an eye towards going after new sources of revenue and new business opportunities. Some of the things that I've seen quite a lot of interest in over the last couple of years, private networks, V2X, vehicle connectivity, what kind of support can mobile networks offer for autonomous vehicles, manufacturing, mining, logistics, etc. All these sort of things are, I think, ripe for 5G to bring these new capabilities to bear.
We know that many operators who already have their 5G networks running and others that are in the process. Dan, what is the current state of deployments, and what is your forecast for 5G ramp next year and beyond?
Yeah, sure. It's really moving quickly, and so 5G as a build out, when people talk about it, it's really quite complex, and there's a couple of different things going on. So I wanted to focus really on sort of the two really different frequency bands where 5G networks are being built. There's the sub-6 gigahertz side, and there's the millimeter wave side. And so the sub-6 is where the majority of work is happening, and millimeter wave is still more in its infancy, and I'll only talk a little bit about that. So specifically about C-band, so this sub-6 gigahertz work, 3.5 gigahertz, a little bit in 2 gigahertz, depends on the region. It's an amazing amount of activity going on right now. And some good examples are what's happening in Korea, what's happening in China. Korea specifically, in the first year of 5G deployment, the 3 operators in Korea, they basically achieved full population coverage in less than 12 months. That's really impressive. And they continue to densify their network. And in fact, they're going to go into the next step. And I talked before about having this combination of 4G and 5G as non-standalone. Korea is going to push ahead with what they call standalone, where you have a network which is just connected to 5G systems, 5G base stations, 5G core. And that's really going to have enhanced improvements, even more than what we've even talked about, what you can get with the current networks. And then you have what's going on in China, which by any metric is just astounding as far as the amount of material that's being consumed. Really, in 2020, 80% of all 5G base stations globally are going to be deployed in China. It's a huge percentage. And this is going to continue. I mean, the rest of the world, of course, is also doing 5G, and you hear about it every day in different countries in Europe and Asia and Africa. But the combination of everyone else, their work and their volumes will match China probably in 2 years. It just tells you the scale of what's going on in the China network. It's pretty amazing. And maybe if I can, just a consequence of this massive build out is really having a positive impact on the supply chain, and specifically on RF semiconductors. And this is really a result of the fact that in 5G, there's going to be this concept of massive MIMO. And maybe at a simplest level, in LTE, you had 4 transmitters per radio up on the cell tower. But in 5G, with this massive MIMO, there could be 32 antenna elements or 64 antenna elements. So, okay, that sounds like a lot, but the real implication here is 1 PA per antenna element. So in LTE world, there was 4 PAs used. Now in 5G, it's 32 or 64. So that's just a huge increase in PA content that has to be supported. And just some rough numbers, in LTE days, maybe 2017, 2018, we're talking about 30 million, perhaps, output devices per year being shipped globally to support LTE systems. 5G, in a couple of years, it's going to be 350 million output stages. So more than 10x. It's a huge increase. And so the market really has to step up and increase its supply. And the other thing I wanted to say about the power amplifiers is we have a new technology now in the mix, prior, all generations, 2G, 3G, 4G, there were LDMOS. LDMOS is very mature. It's been used for many, many years. There's a new technology called GaN, gallium nitride, which is going to offer improved performance, specifically in the area of power added efficiency. And in fact, I expect the number of GaN PAs will probably be about half the market next year. And by 2024, it could be almost 3/4 of the market as far as the types of PAs shipped into the market. So it's very impressive, very rapid growth. So that's actually pretty exciting for PA suppliers. And then really the other part of the market that I was going to touch on was millimeter wave. And really it's not as big a market as far as how many deployments are going on right now. It's actually being led by the US. There's more work done in the US right now than anywhere else in the world. And it's primarily being done by Verizon. So Verizon's going to take this technology. Millimeter wave signals don't travel as far from the base station. I think people understand that, but it has huge bandwidth. So it's a complementary piece to the whole 5G solution where there's going to be millimeter waves in high, dense urban areas, lots of data being consumed. And then the US, when it deploys its C-band network in 2021, will then have this combination of millimeter wave and C-band, which will be the optimal solution for a 5G network.
Thanks, Dan. I appreciate the market details. So Tom, from a technology point of view, what are the essential building blocks needed to unlock the full potential of 5G?
Well, again, let's reiterate just sort of from an operator's perspective and why they would spend money on deploying 5G is, every operator in the world is basically in the same situation where they have declining revenue per customer and they're having to provide more and more services. So there's a real need to cut costs and also find a new source of revenue opportunities. And so that's all started in 4G and it'll continue and accelerate in 5G. One example would be the densification of the networks that we're seeing now. Quite a lot of small cells, particularly here in the US, a lot of fiber being put down now, and a lot of that with an eye towards accelerating 5G when they're ready to actually deploy those radios that the infrastructure will, in a lot of cases, already be in place. So there's going to be more cell sites, maybe not more macros necessarily, but probably antenna swapping out, massive MIMO, those types of things. But a lot more small cells look like they're finally going to be deployed. And higher order, as Dan had already addressed, the number of components that are required to build these things when you go from 4T or 8T to 32 or 64, obviously going to have a lot more RF content. And one of the things that's bringing with it is a problem, both on the digital and the analog side, is power consumption and heat dissipation in these massive MIMO systems. It's a real issue, and everybody's looking for a way to get these things addressed. And now you look at another trend that's continuing is the power. And each of these radios continues to, go higher and higher and higher. It started out at a couple watts, now it's 20. They're even talking, I think, upwards of 60 watts per radio on these things. So that's going to just compound this same issue that the manufacturers have and the carriers, frankly. The power consumption and the cost, such a huge part of every operator's budget that needs to be addressed. So any improvements in semiconductors that can address these challenges, I think, would be most welcome.
Thanks, Tom. So you mentioned that higher order MIMO is one aspect of 5G infrastructure. Jim, what technologies are needed to ensure the best network performances?
Well, I think Dan and Tom both touched on really the couple of the different choices that are available. There's for the radio, the RF power portion of the radio, there's really primarily two. That's LDMOS, as was mentioned. That's silicon-based technology, and that's been around for 30 years now. It's a highly reliable, cost-effective solution, and has really been the choice of most OEMs from really analog systems all the way to where we are in 4G today. But with any technology, there's trade-offs, and with these new systems coming on, that and as you can imagine, you go from the 4-transmit or the 2-transmit, 4-transmit, or even some 8-transmit systems to all of a sudden these 32-transmit systems or 64-transmit systems with RF paths for each, you can imagine the size and weight and power consumption really becomes a critical aspect that needs to be looked at. And that's where really gallium nitride comes into play. It does have inherent advantages over LDMOS, where that fits really nicely in those higher order systems. Clearly, that was, as was mentioned on the power consumption side, the higher power out efficiency reduces that power consumption, and it was, as was mentioned, is a really a cost adder for the operators as they operate their networks. But the other side of things, or another aspect of GaN, is the power density. Basically, that means the amount of power you get for the same area of die is larger for a gallium nitride. So that allows you to shrink down the equipment. This equipment resides at the top of a cell tower. That real estate, for lack of a better term, in most cases you're renting that. So the smaller the radio up there, the better for an operator. So that's clearly another advantage that GaN provides. And as you shrink that from a size, also the weight is another thing that needs to be considered. So all of those things combined really point towards now gallium nitride being a leading technology as we move into the 5G arena here, and certainly those advantages will come to play. Now, the only reducing those systems costs for the operators by using GaN is just one aspect of getting the cost out. Now, there's clearly other things that need to be looked at, and one of those is further integration of the semiconductor components that are utilized in a radio. The more that you can add functions onto single devices, of course, that adds to performance, adds to size and weight, and certainly will reduce system cost quite a bit.
Thanks, Jim. I'm glad you mentioned integration as an important part of 5G radios. For Pierre, could you explain a little bit more about why this is so important?
Yeah, thank you. Dan and Tom went through the increased complexity of the 5G networks with domination of 32 and 64T systems. What that means for us as semiconductor vendor means that we still need to strive for the highest efficiency possible. And that has an impact on the overall system cost. And the opening of our fab here in Chandler this month is part and parcel to that strategy of delivering the highest performance to the market. But another aspect of that is that if you want to look at the overall system cost of those 64T systems, a very good way to reduce that cost is to integrate more and more functionality on our product, in our products. And so with that in mind, we developed a full portfolio of integrated modules, 50 ohm in and out, that also have an added benefit for a lot of our customers is that along with the complexity of higher order systems, there is also a multiplication of power and frequencies that are used for the deployments around the world. And the use of those integrated solutions means that for someone who's designing a system, they can have a fully drop-in solution that works across frequency and power that they can use in all of their systems. So that brings a lot of benefits in terms of time of development and time to market for the OEMs that use our products.
Thanks, Pierre. So we've heard a bit about what 5G is and some of the technologies required to make it a success. Jim and Pierre, can you explain why NXP is positioned well to support this?
Maybe I'll start and then I'll hand over to Pierre. I think the first thing is important to mention is the history in the market for NXP. We've been serving this market for 30 plus years. We've been a clear leader in this space for that entire time. As I said prior with LDMOS and now moving into gallium nitride. And even though gallium nitride is really now just emerging because of its inherent advantages over silicon, it's also worth noting that NXP has been investing in gallium nitride for nearly 20 years. That started with, for those that have been along in the industry long enough, remember the CS1 fab, Compound Semiconductor 1 fab, which at the time was the world's largest compound semiconductor fab. We started our investment in gallium nitride way back then. So we've got a lot of history, a lot of experience with both those technologies. And the other advantage, clearly, that NXP will bring now is, as Pierre mentioned, is the opening of our new fab in Chandler. Certainly allows advantages of being able to control a lot of different things that maybe you might not necessarily be able to do if you weren't vertically integrated. Technology development, of course, is a big part of that. And also, being able to control cost reduction is going to be a huge focus, will continue to be a huge focus, and that's what our customers and their customers are really looking for. So we were able to control that aspect better as well. And certainly, as everybody knows, this market is highly dynamic. It goes through swings up and down. We're in a huge up one right now, and having the ability to really react to those market swings is something that we pride ourselves on as well. So, another advantage that I think NXP brings as well. Just back to the technology development, we have IP that specific to the gallium nitride technology that gives us quite an advantage in the market. Maybe I'll hand over to Pierre to maybe expound on that a little bit.
Mm-hmm. Well, thank you, Jim. So I absolutely agree for all the reasons that we went through in this webinar. The investment that we have in gallium nitride is paramount, driven by the benefits in power rated efficiency. But if you look at the full system design, you need that power rated efficiency. But at NXP, we have had a continuous investment in LDMOS, in silicon germanium, and combining those technologies inside one integrated module that's going to not only focus on the TX performance, but include functionality of BIOS controls, of increased efficiency at the system level, will bring benefits in terms of compactness of the solution, enable cost saving in terms of the cooling requirements for those systems. And that's what an integrated solution delivers to the market. A combination of IP that we own at the GaN level, but as well in LDMOS, in silicon germanium, and in the overall architecture and design of the PA module. And with that type of integrated solution, we deliver maximum value to the market.
Great. So we've heard the perspective from NXP. Dan and Tom, what is your view on how NXP is positioned in this exciting market?
Well, certainly, as mentioned, it's really a great circumstance to be able to enter this new 5G market from a position of strength. And so NXP, we model the market as well, and fully agree that NXP is the leader in the PAs for the markets, and started in LDMOS and is continuing. And that provides a real benefit of having established customer relationships, especially when you're trying to introduce new technologies, because customers really want the best performance, but they want low risk. And so one of the ways you can offer that is by having that established relationship to work with people. So I think that's a real benefit that NXP can bring to its customers and to the market. And as mentioned, GaN is still relatively new, so there's still, I think, a lot of work to be done to get cost out, to improve the performance even further from where it is today. But that's hard work that can be done. So it looks like all the pieces are falling into place, and so it looks pretty positive.
Great. Well, I can't really add a whole lot to what Dan said, other than it must be a good market because there's a lot of competitors are jumping in right now. So I think everybody is seeing the opportunity, and LDMOS is a pretty mature technology. I mean, any gains that you're going to make now are very incremental, whereas GaN is still, relatively speaking, in the fairly early days. And if you look at the gas market, for example, and how long that took to mature and how it continues to improve, I think that it's reasonable to expect that you're going to see similar types of and scales of improvements in GaN as time goes on. But at the end of the day, it's really going to depend on who has the ability to innovate and scale and deliver things at a cost-effective price.
There you have it, straight from the experts. I hope you enjoyed learning about the recent trends in cellular infrastructure and how GaN is impacting the 5G market. Thank you, Dan, Tom, Jim, and Pierre for your time and insight.
Yeah, thanks very much.
Thank you. My pleasure.
Right.
Bye.